Okay, so good morning, good afternoon to all of you. My name is Alex Kaffenberger. I'm with the Chief Data Office in the European region, streaming from Munich, Germany right now, and I'm really happy to be with you. I hope you can hear me loud and clearly. So I brought some use cases, some AI use cases for you today. Before we will go into those use cases, I would like to have a look with you into some historic data. I know predictive analytics, predictive maintenance is really key right now, but to also mind or have a look into historic data is very, very helpful and gives us some insights. These are two quite famous pictures that have been used in quite a lot of AI presentations in the past. It's about the election of the two popes in 2015 and 2013. It shows a bit like how the behavior of the people changed. You might have seen those pictures in the past. So what we see is everybody's using smartphones, devices, everybody's streaming, recording, generating and creating lots of data. And what happened in 2021? It looked a bit like that. Italy was hit quite hard by the pandemic, so nobody was on the street, of course, or on the streets, of course, but the streaming data and the data usage exploded. So I'm really curious to see the latest data. So we are already in the 70 zettabytes of data being created, captured, consumed, streamed. It's insane what amounts of data we are really producing. What does this mean for the users? The users expect, of course, a perfect experience with their devices. They expect to work from home. They expect to stream. They expect to use online games. So for them, it's clear everything has to work perfectly with their devices. And for us, IT providers, we have to make sure that all the platforms are stable and that we can really deliver this performance to all the people. So this is quite a bit of a challenge for us as well. And that's why we as global IT organization also like to partner with other big players in the market like NetApp to provide this performance to the users, to all our customers. When you, let me just quickly switch forward. We have a long and trustful relationship with NetApp. Over 20 years, Fujitsu maintains over 31,000 NetApp systems worldwide, and we created platforms, AI platforms, and architectures together with NetApp to exactly provide this stable platform for organizations, users, and our joint customers. And why is it so important to have a stable AI platform? When you think about those AI platforms, how they are being set up, there are hungry beasts inside those platforms, like NVIDIA GPUs, Intel chips that require constant data streams. So they need to eat, they need to be fed with data. And we as NetApp and Fujitsu, we have to provide those constant data streams into those compute platforms. That's why it's important to have a stable AI platform. And when you think about those perfect features like the snapshot that NetApp provides for backup of whole and entire systems within seconds. This is exactly what we need for AI platforms to have no interruptions and to provide this constant data streams into the compute environments. So let's now jump into the first use case. It's about arena optimization. So when the pandemic started 2 years ago, Fujitsu asked the employees to come up with ideas how to support the society, how to come up with smart ideas, to overcome limitations and restrictions. And out of this idea and request, a whole concept for a safe return to arenas and events appeared, from entry management to seat optimization. Just give you a small idea about entry management. Fujitsu has a cool technology that allows you to enter a stadium without any ticket, without any ID. The only thing that you need is the palm of your hand. The veins in your hand, and our scanners can see those veins, can identify the visitors of those arenas, and can allow access. So you don't need to bring anything else anymore. You can even pay with the palm of your hand. This technology is called palm vein technology. And we use it in different environments, and for stadiums it's perfect because so many people go there and you don't need to touch anything anymore. You just have to hover your hand over the scanner, and then you can pay for your drinks, you can pay for your food. That's just a perfect user experience from my point of view. But that's actually not the case I wanted to show you today. It's about seat optimization. So the idea is to return to stadiums and have a safety distance to other individuals, other groups. That's required in a lot of regions in the world. So let's say 150 to other groups and individuals. And when you are a stadium provider, what you can do is you can say, okay, since I don't have any possibilities to organize this in a proper way, I can only allow two people to sit beside each other, then 2 seats free, another 2 people, 2 seats free, like a chessboard. That's what they can do. With this kind of seating um, possibilities, you can only occupy probably 46% of an entire stadium because there are ways, there are posts, so you won't reach 50%. If you do it in a smarter way, then you can reach up to 64%, 65%, and we can do this with smart technology like the Fujitsu Digital Annealer, which is a quantum-inspired chip. And with this chip, you can allow larger groups to have a certain safety distance to other groups. Now you might say, why is this so hard to calculate? Is this really difficult? I can give you some examples about that. If you have a stadium with 500 seats and you allow groups of 2 and groups of 3, then you have possibilities 5 times 10 to the power of 1,125 possible scenarios how to position those people in a stadium. This is insane to calculate with standard technology. You either need a quantum computer or a quantum annealer. They are a bit limited right now in the world. So that's why we need other technology. And that's where our Fujitsu Digital Annealer comes in. We can calculate this within a few minutes or hours, which is still quite some time, but you can never reach this time with standard technology. And that's why we bring in technology here so that we can organize a better scenario while seating people in a stadium big like that. And why is it also good for the people? Because you can allow families to go back to the stadium. So imagine a father with 3 kids wanting to go in the stadium. You would have to rip this family apart in 2 by 2 by 2. So it's not possible to, if you go with small kids, to go as a family in a stadium because you will be ripped apart. So with our technology, we can allow larger groups on the one hand, and on the other hand, we bring back some more revenue to the stadium owners, even with a small amount of more seats that they can sell to their customers, to the groups. They can make a bit more money, and that's good after the pandemic. So nice use case to safely come back to stadiums. Another area of use cases that I brought to you for you today is about non-destructive testing. So imagine wind power generators, the production of those turbine blades. They have to be of highest quality. You cannot allow damages and defects in those turbine blades, because if they are in production and then they break, they might fly through the scenery. That's impossible. So you have to quality control those blades with visual quality control. So individuals have to really look at the entire blade. Also with X-ray pictures. So you have to visually monitor X-ray pictures. This takes an amount of time, an insane amount of time, 6 hours for one blade. This is definitely tiring and quite long. We thought we can do this better with AI. We trained pictures of defects and we can reduce this time to 90 minutes for one turbine blade, and we are still improving. So this is a nice possibility to use technology to improve the quality and to free people from quite tiring work, to be honest. We improved this methodology, these algorithms, and we do this now with glass vials, and those glass vials are also used for vaccines, more important than ever. So we make sure that there is no contamination in those vials, that the glass is perfect, because we cannot allow that vaccine is being used from defective or contaminated glass vials. And another step to the right, we improved it even further together with Fraunhofer. When you think about the production of very cheap items like plastic caps, it's not reasonable to inspect each and every plastic cap because they are so cheap. I mean, it's mass production. What we do here is to monitor the entire production scenario. So how many sensors there are, how many sensors available in the whole in production environment. We take the data from those sensors and create a model of the entire production process. And this model is being monitored. And when this model breaches some thresholds, then we can have a look into the production process, can probably discard some of the batches of the caps. So we are not monitoring the item itself anymore. We are monitoring the production process and create models from the entire process. So an entirely new idea to quality control, in this case, cheap plastic caps. So let's step into the next one that I brought to you. It's about augmented operation using robot arms. So imagine you are a producer of robot arms and you are selling it all over the globe to your customers sitting probably in Europe. Right now you cannot visit them because of the pandemic, or it's quite tough to do that, but they still expect you as a company to provide services to them. Maintenance services, also training services, so they require your help. How do you do that? And for that, I brought a small video for you. Probably we can play this video now. So you are a user and you bought a robot arm from the company. Let us kick this video off. And you have a question how this robot arm operates. So you need some help. So you start your interface, your support interface. That's happening in a virtual reality. You are in front. This is your hand, and you are clicking on this interface and requesting an agent for help. There's our agent on the right-hand side. She's an avatar in the end. She's a real person, but streaming in as an avatar. On the left-hand side, lower down, you see our robot arm, and here's our support agent. Hi. Thanks for helping. And she can show now how to operate the robot arm. Even if she's not there, she can interact with this physical robot arm system in front of her. Then you can repeat it. You can show what you've learned. Okay, it's working well now. You're operating in the same way, even if you're physically in front of the robot arm. And yeah, you got some help from this agent now. Wave goodbye. Thank you for your help. And you close your interface. So this is a perfect case that shows us how OT and IT can interact. In this case now in a support scenario. And I think this is a perfect experience for end users to bring in a virtual reality some avatars that help you in your daily work, in training scenarios, when you have issues with some hardware or some software that you have bought. The last use case that I've brought to you is about disposal of space debris. So we have not managed we've not only managed to pollute our oceans with lots of plastic, we also managed to collect a lot of trash in our outer atmosphere around our planet. Old satellites, parts from satellites, and there are some projects that want to remove those this debris. So we are in a cooperation with Astroscale, University of Glasgow, and AWS, and the idea is to collect this debris and bring it back down to Earth. It can burn up, and then it's no threat anymore, because when manned missions go up in space and they are hit by those parts, this can have severe damage. That's why we need to remove those parts around our planet. How can we do that? And I also brought a video about that, so probably you can start our last video. When we go there with satellites, we cannot just go there without any plan. We have to calculate which part to get first, which second, and which part at last. These are hard to calculate mathematical problems. Some of you might know them. They are called traveling salesman problems or knapsack problems. So you have a number of items, and you need to calculate which of those items to collect first. They might have a different quality. Some of them might be bigger, some of them might be smaller, some of them might be a bigger thread, some of them might be a smaller thread. And to do the calculation through all of that, you actually need really powerful hardware or algorithms. Best case, a quantum annealer that is able to calculate all of those routes in space. Since we cannot bring a quantum computer to space, we thought it might be a smart idea to bring the digital annealer or quantum-inspired technology there, because this technology can calculate it really fast and can help the satellites to navigate there in a smart way, to pick the right parts and to bring them back on Earth. So we can stop the video here and go to the last slide. Thank you very much. So to come to a conclusion, we have learned from many IT projects that there are some issues and some things that you have to keep in mind when you start your AI projects. It's about the right IT infrastructures. May it be cloud, may it be hybrid, may it be infrastructure in your own data center. There are legal hurdles. Am I allowed to use this data to train my model? Do I have enough budget? Is my organization ready to deal with AI projects? Do I have the right culture to create, share, use data? Do I have the right know-how? And in the end, is there enough data to train my models? So it makes sense for organizations, if they want to start an AI project, to collaborate with IT vendors who have experience and the required technology, to pull partners from their ecosystems, the necessary skills, the experts, needed add-ons. And this is one of the reasons for us why we like to collaborate with NetApp, because there we know that we have a stable platform and that we can start from there and provide this right amount of technology and skills to our users that they can have a perfect AI experience. And on my last slide, just would like to show you that we really have fun with our AI projects. And this is displayed here. This is the number of AI patents worldwide. And we are quite proud to be in the top 10 of this list. So we are happy to serve you in your next AI project. And thanks for your attention. And I wish you a great experience today and a nice meeting. Thank you very much.
So a big thank you for him for kicking off his day extra early. So it was really great to sort of, get a bit of a foundation for some global use cases and applications. What we're looking to do is bring things closer to with a bit of a panel discussion. So I'll welcome Silke back up to the stage and she'll be able to introduce the panelists.
Thank you. Back on stage while they're setting up, I would like to introduce the experts that are joining me up here on stage. So first up, I would like to introduce Matt Herford from NetApp. Matt, there he is. Matt is the NetApp VP Systems Engineering Director and CTO for APAC. That's one title. It's a big title. Over 20 years experience in IT industry, virtualization, data analytics, hybrid cloud solutions, but a big focus on big data.
Absolutely.
As I said, and the value that data analytics can bring to
I'm
organizations?
always looking to understand what data scientists are trying to do so we can help them with their data challenges.
Fantastic. Thank you, Matt. Next up, Rod Brown from NVIDIA. There is Rod, thank you. The sales director for ANZ for NVIDIA. Welcome, Rod. Rod has a background in prototyping, design, commercial rollout of networked and clustered systems at Cisco, Oracle, and NVIDIA. His focus is on both practical and lighthouse use cases of AI and accelerate computing for government specifically.
Yes, it is.
Thank you. Welcome on stage. And last but not least, Dr. Cormac Purcell. Welcome from Trillium Technologies. He's the program director at Trillium Technologies Australia, where he builds public-private research partnerships to tackle sociological and environmental challenges. So Trillium works with partners such as NASA to apply AI and space data to natural disasters, for example, ocean health and space science. So you would have been probably very interested in the space debris example.
It did strike me.
Yep. Cormac is passionate about what he does, spending over 18 years as researcher and recently a lecturer at Macquarie University, background in astrophysics. Welcome on stage.
Thank you very much.
Please, gentlemen. I would probably go to this side. All right, so we talked a little bit about AI. Obviously, we heard really, really interesting things from Alexander, who joined us at what is probably 4 a.m. in the morning in Germany. I am from Germany, so yep. But one of the main things that I mentioned in the introduction is embarking on that journey. It's quite hard. So how do you think can organizations embark on their AI journey? And I would like to probably throw to Matt first.
Thank you, Silke. Yeah, it's a good one. And look, as the data guy learning about AI as we go along, I think that I heard some strange things at the start of AI, like, it's finding needles in haystack, it's solving world's problems, when reality is, I think that the same project governance processes we put around any successful project stand true, right? If you have a really defined outcome, I think the difference with AI is we then teach the machine to find that outcome for you. But having that defined outcome, having that use case very clearly defined is super important, because there are 3 real things that you're going to have challenges with. People. You're going to have a very clever ecosystem to work with to get a successful project. NVIDIA, NetApp, Fujitsu, data scientists, it's going to be a family. It's going to be more people than you probably would normally work with to be successful. Data, I'm the data guy. You don't want to overcomplicate it. You're going to have multiple data sources. We don't have to have proprietary file systems, parallel this, Hadoop that. Let's keep it simple with object and NFS. And the third one is infrastructure. And that's what this test drive is all about, accessing the right infrastructure, an integrated stack of best of breed, so you can focus on getting results quicker. I think they're the most important things.
Excellent, thank you. Rod, from the NVIDIA side, something to add to that?
Yeah, so I think a large part of it's just is an education process. I mean, being able to define, projects and things like that, you have to know where you're going, and before you know where you're going, you have to have some idea of what's possible. AI has a variety of connotations for different people in different contexts, just because of the fact, we've got some significant, science fiction and media and entertainment background around how people associate themselves with it. And that brings with it some, unrealistic optimism and some overt, negativity in certain circumstances as well. So just being, we spend a lot of time trying to be very pragmatic and practical about what it's really good at doing now. And a large part of that does revolve around, the access to data that you have, and its relevance to yourself as a company or a government organization, and what you can put it to practice for. And then it's also a part of, how can we actually make use of this for, whether it's for government purposes, for defense purposes, or for, for an enterprise to be successful. So how do we get it comfortable to be that data to be utilized? Is it able to be utilized in ways that we want to do? That's particularly, an issue in healthcare industries where, the consequences of things being shared inappropriately have the most negative connotations, I would say, in terms of what can be done and manipulated. But there's then also the fact, okay, ultimately we either need to make money or make some progress in the use of this. That's how these projects get driven. So how do we fit something that is so potentially optimistic, but also has some of those, people and culture issues into, a practical mainstream project? And, setups like Fujitsu and NetApp have put together are a way to do that. So you can get on, have a look at, information in a secure sort of way and test things that you may not be used to utilizing in practice in ways that are safe and that you can bring people on board and start using it. So that's we spend a lot of time doing that. I'm very thankful that, both Fujitsu and NetApp have put this together and that you're also interested in hearing about it. So
Yeah.
over to you as a practitioner.
Yes, the doer.
Yeah,
The doer.
Yeah, I think when we're talking about the research and higher education space, it's so broad that you get a very broad set of users. On one side, you have new students who are coming in and don't know how to use AI at all. And on the other side, you have research teams who are very AI proficient and can deploy AI at scale. And so when you're covering those users, you're trying to do many things at once. And just picking up on one of your points there, it starts with education. It's good to have the ability to experiment, and I think that's what the AI test drive facility will offer, is the ability for some of the people who are still working out exactly how their workflows work to go and try out a facility which they wouldn't normally get access to. And the biggest problem that they're going to try and overcome at the start is data management. There's a paradigm in artificial intelligence research at the moment where a lot of effort has been expended finding a slightly better algorithm and a slightly better way of finding objects in a scene or predicting a time series. And we've reached a point where it's not quite plateaued, but we've got fantastic algorithms now. And really the major changes are going to be driven in the future on how we manage our data sets. So it's looking at the biases in data, looking at how we can go back to the data and change and tweak and then go around an iterative experimental cycle. And that will deliver the best outcomes. And I think, Matt, what you were saying about managing all of that data, that requires the right tools, and it requires the ability to make that iterative process work well. And that's, I think, what we're here to really promote.
Yep, beautiful segue into the next question, tools, talking about tools. So AI is on everybody's radar. How do you start? How do you go about selecting the right platform for your specific AI solution? So maybe Rod first this time.
Yes, I think it really depends on what it is that you're looking to do. I mean, most of the requirements of AI to be uniquely valuable to a business revolve around the data that they're trying to work on in relation to that. And there's a saying, data has gravity, right? So you kind of want to put the infrastructure and things like that close to where the data is being generated or where it already exists, right? To make best use of it. So that's kind of a logical place to start the experimentation. And obviously what's being put in place here is articulated towards a more centralized iteration of that with large data sets, and that tends to be where the largest insight is most quickly drawn from. What's kind of a nice value add on top of that, obviously, is that you can, whether you start in the middle or you start at the edge or somewhere, at one extreme, you'd like to be able to extrapolate the use of that over time into areas that are either incrementally beneficial to yourself as a business or to partners that you may want to work with. So kind of looking at the software and the tools that you may be evaluating. This is particularly pertinent for researchers and things like that, right? Try not to get too far down a rabbit hole on one particular area too soon and wed yourself to that. Try out some different things, see what works in with the mainstream of your business and also the people that you want to do business with. Ultimately, whether that be in a government framework or whether that be partners or fellow researchers. And I think that's looking for some level of consistency that not only you can trust people to say, but you've got evidence out in the market and that you can use yourself. I think that's a critical piece, because if we want these things to flow together ultimately and work nicely, then there has to be a level of integration there that you may not naturally do for an internal IT project, but I think it'd be really helpful when you're looking outbound. So
Yep.
that's me.
Yeah. I think NetApp and NVIDIA's biggest data partner, right? So your AI project's going to be fueled by data. And the last thing I want to do is increase that barrier of entry to data scientists. If I try and train a data scientist to understand how to get the most value out of my storage array, I'm making a massive mistake. So what we've done is we've integrated that into the stack. We've built these data science toolkits, which are Python scripts. They still enable a data scientist in the languages and code they want to use to go and create the ability to snapshot, to clone. Perhaps there's a golden image of code, a golden image of the data. They create an instant copy of clone. Off they go on their coding path. They're taking snapshots on the way they can roll back to. They don't need to know how we do that. They just need to know the scripting they need to include in their code to get that done. So that's the very first thing. We've heard a little bit about edge to core to cloud, right? You inference at the edge. Perhaps this, the AI is running, and you gave a good example earlier, on a laptop with a surf lifesaver looking for sharks. Perhaps there's a data lake inside your data center. Perhaps you're looking to leverage cloud and some of the AI engines in cloud to test your model or deploy your models. NetApp has software-defined data management platforms across all of that. Light at the edge, best of breed in the core, and then native in the cloud. So one set of APIs, one set of governance, one set of security, one set of data management policies to manage your data across all those places. And then we overlay that with flexibility. So the ability to say, I'll give you a reference architecture for how you deploy NetApp and NVIDIA and the toolkits if you've got the power to do it and the capability to do it. If you want to buy an appliance, we can sell you an appliance. If you want to come and build and start using as a service from Fujitsu, we can do that right the way through to managed service offerings from CapEx to OpEx. So it's lowering that barrier of entry for the people using the platforms and how you're going to consume the platforms, I think is super important in that decision about what you choose to go and do.
Very valid points. Thanks for mentioning that and doing the advertisement for Fujitsu there. Thank you. Cormac, again, you're the doer. You make the magic happen. What is your take on that? Your personal experience and challenges that you've faced?
Yeah, well, I'd just like to say at the start that AI is such a broad term, and how it's used in science is very broad and quite different depending on where you look. So, for instance, you might be doing data discovery with science and trying to figure out what's in a data set. Then you won't be using machine learning where you give it labels and then try to teach it an outcome. What you'll be doing instead is you'll be trying to figure out what patterns there are in the data. So unsupervised learning. And that's quite a different tool chain than if you're doing supervised learning. When you're a researcher starting out on that journey, trying to figure out your way forward, you can go down many different rabbit holes of dependencies and installing different scripts and trying to figure out which tool chain you want to use. You want all of that to be abstracted away from you. You want to be able to say, okay, there's 3 or 4 different route options that I have here that I can rely on because they've been tested, and they've been tested on hardware that works on the edge, and they've been tested on hardware that works in a data center. And it's given me a recipe where I can just abstract that and go and do my science. And then you're not having worries about sharing your data sets, sharing your code, because everything works off the same dependencies. And so I think that's the very first thing that you look at when you're trying to choose a platform. The second thing is scaling as well. So when you're a researcher at the very beginning of a machine learning project, you will be doing lots of experiments. You'll be trying lots of things. They won't work. You're figuring out how your data works. You're figuring out how your algorithms work. And a lot of what you produce will be rubbish. Or at least, will be informative rubbish.
It's part of the process, I guess.
Exactly, part of the process. It's the scientific process. But when you have settled on a system and your system does something, so for instance, I work in bushfires. Imagine that you want to do some sort of fire prediction. Eventually, you'll want to roll that out as a service or some sort of module that will be of use to someone on the ground. And you want that to scale to the edge and to large systems where it may be deployed. And so when you're starting out, you want the guarantee that will be easy to do as well.
Thank you for that. And this is, I think it really highlights the fact that there's no one AI solution. It really depends on what you want to do. So many different aspects. And we talked now a little bit about, how you start your journey, but now let's talk about what it can do. use cases. How can organizations really harness the power of AI and transform their business? It's all about digital transformation, what we always talk about, and AI has a major step or a major part in that to play. So how can we do that as a company? And I think you've got some use cases you could share with us, Omik.
Yeah. So I think there's a lot of buzz around AI, and a lot of folk want to adopt it in their organizations. And I can speak mostly to research organizations, and it's an enabler there. But one of the questions that needs to get asked is a particular AI method better than curve fitting, or somebody going through a document by hand to pick out whatever they need to pick out?
Yeah.
AI is particularly good at certain things. One of the main ones is data fusion. So we're that wonderful slide that was shown at the start, how many zettabytes of data are being generated in the world. It's only getting bigger, and we're getting many more things measured in the world, whether it be because of satellites passing overhead or sensors deployed on the ground. And all of these provide information about the world with uncertainties attached to them. Now, artificial intelligence or machine learning is very good at melding those into a single model and being able to make a better conclusion based on those data. So that's the very best thing that it's of use for. When you take the learnings from artificial intelligence, you can deploy them on edge devices, and you can automate processes and provide decision support tools for people in the field gathering data, or for particular people going about their everyday lives or doing their everyday jobs. And some examples that I've worked with is I've worked with Surf Lifesaving New South Wales, where we've been testing a scientific approach to a shark species detector, run on drones that monitor the sharks from about a height of about 60 meters. And if we can do that well, then you provide a decision support tool that compensates for fatigue and glare on a screen and environmental conditions, where you have a human who's really trying their best to save lives and make beaches safer, but all of those other confounding factors make it more difficult. And AI doesn't get tired and doesn't have issues with being able to see a screen in bright conditions. And so it can be a decision support tool saying, okay, we've got something dangerous here, now you need to pay attention. And it's a similar way in bushfires, so predictive models and bringing the types of weather and fuel load data together into a cohesive picture. So there's many applications. If we can do it right, if we manage the data right, and if we manage the uncertainties right all the way through the tool chain.
I loved the examples that Alexander talked about, the space debris. I mean, amazing projects, right? But these are very, very relevant things for Australia, shark, bushfires. So, yeah, thank you for sharing that. Rod, from the NVIDIA perspective, what have you seen? What are the key outcomes that our company's driving for?
You know, I'd agree that they're quite varied, and there's certain things that AI is very good at the moment, and you know, and the category of there's probably three that are kind of adjacent. I mean, image and video processing that it's incredibly good at, because there's large bodies of data and stuff like that that are captured, and we can centralize and we can learn quite easily from that. And these are things that people would find. There's all sorts of esoteric use cases. The one you used is, you know, relatively esoteric, and space debris is another one that wouldn't immediately jump to mind, not to my mind anyway. But there's large collections of information that are already available around those things that people won't trawl through because there's insufficient motivation and time and, you know, boredom's associated. But AI is very, very good at those types of things, right? And that allows these types of decision support systems where people wouldn't commit the time themselves, but if they're given some insight that maybe these things are, you know, closer to being, you know, possible to make a decision on than they otherwise would have been, that allows for, you know, things to happen that wouldn't happen organically. And I think that's a really exciting element of it. You know, the natural language processing around text and what that can do in terms of whether it's legislative, you know, purposes or just, you know, the written word, broadly speaking, and making that more accessible to people. in different languages is something that AI is already quite good at, and it very soon will be incredibly good at. And then the third element is, how do you help people, interact with that? So there's a data analytics side of things, which we've focused on today. There's also how do we immerse people in these things, which is the flip side of the video and the image analytics, right? So how do we help people relate to some of these esoteric things in context that makes sense for them, either in a personal or a business context, right? And AI, the same infrastructure we use to do a lot of this, complex math is also very good at rendering, high-speed graphics and things of that nature. So I think there'll be a bit of a fusion of how we interact with certain data sets and things like that. And research space will certainly be one of the first places we do that, because we have to simulate things in those areas. So whether that's at the microscopic level or subatomic level, with which we've seen with COVID, or at the macro level where we're simulating events in space, I think that'll be a lot more accessible to a wider range of people. And I think that's going to be a really exciting time for science and the people who work with science.
Yeah, I can give concrete examples of that. So Australia is embarking on new adventures in radio astrophysics, with huge instruments, linked arrays of radio telescopes out in WA. And the data rates from those, the analogy is like drinking from a fire hose. Like, as an astrophysicist, what we used to do is sit down at a laptop and examine the data ourselves. There is no possibility of doing that now. You need AI and you need advanced visualization tools, especially, to find meaning in the data. So the AI needs to go in, needs to figure out, oh, there's an interesting pattern here. We should flag it for a human to look at. But I think one point is that humans in the loop are always going to be needed as well.
Yeah, we're still very far away from being able to, represent a human brain's capacity for intuition and things like that. That's still some time away. So, getting an explainable decision out of an AI system that's at all, versatile is not particularly possible outside of a very narrow space, I'd say, at the moment. It will become, that's probably a next decade challenge in terms of ethics and things like that. I think what is good, though, is that people are aware of those concerns early, so we can make allowances for it now. But yeah, what it is really good is very much that decision support side of things, and is there a decision to make or is there not? And we can do it about bigger problems than the human brain can concentrate on, for or problems that we would normally need to have a network of people that don't naturally choose to agree with one another, absent of some deterministic information, right? So I think that it'll be very useful in that sense.
Yeah, and you make a good point. I mean, the whole discussion around ethics and AI, obviously that would be a whole different discussion and a longer session probably. But at the moment, the decision support that we can get from AI to make better or faster decisions, depending on the problem that we have, is certainly something where the value is. But from your perspective, what are some of the great outcomes we can drive with that?
Yeah, three quick examples, I think. We work with a company called Nissi, who is a Hong Kong-based robotic surgery company. And during COVID, obviously their business model suddenly looks a lot better in terms of profitability. How do we train robots to go and find lesions in lungs? How do we use things like NVIDIA Clara for medical imaging processing? But interesting with those guys, it was, we want resilience. If we take this from what we think it can be into production, we want to have backup and continuity and a lot of those things in ITIL and things that we sometimes forget about as we move these projects into production. So we had to build a whole complete, more normal IT ecosystem around that solution, as well as providing the ecosystem to drive that results of this robotic surgery. Another customer who makes tires for aircraft. And this is an edge to core to cloud story. They wanted to understand what the wear and tear was like on these tires. How was their development working? Did certain runways, did certain climates, certain aircraft impact the usability of the tires? This is a photograph. Somebody takes a photograph of the tire, gets uploaded into the core, held in a data lake, and then processed in the cloud using analytics in the cloud. So a great story of how we can use these use cases, and there are many, right, of how do I take a photo from my mobile phone and embed that in my AI process to drive real results into R&D or whatever it might be? And the third one's around retail. We work with a lot of retail organizations across APAC and in particular ANZ. Theft. What are people buying? All the way through to spillages, all the way through to advanced modeling around dynamic pricing. How do I have the right pricing for the right person at the right time inside supermarkets and those kind of things? So this huge broad, I don't disagree entirely with these two gentlemen in what it's good at today, but the application of those use cases is huge and varied. And I guess the story is that we're here to help, right? Here to help organizations, if they've got an idea, come and jump on the test drive. We can validate your code or we can benchmark your performance. I think they're the two key use cases that the test drive will give you if you want to be involved.
Exactly. That's what we're here for. You say it nicely. To bring these technologies together for the perfect solution for your needs. Thank you so much, Cormac, Roth, and Matt, for sharing your insights, the expertise, giving us some ideas. I think it's such a great topic. We could talk for hours, obviously, but we want to open it up for Q&A, and the questions can come either from the floor or from our other locations or online. And I hand over to Matt again.
Thanks so much. A golf clap for the panelists. That was fantastic. I echo Silka's points. You can truly talk to this subject for hours and hours and hours. It's great. And some of the use cases that we were walking through are so cool as well. Sharks. So I would like to open the floor for some questions. We've got a first one. Hot and heavy.
Thank you very much for a wonderful event, great location and fabulous panel. So thank you. Cormac, you made some interesting points to start off with, and the one that stuck with me was data bias.
Yes.
And then you went on to what is the model we're using, and are we using self-learning models, etc. I guess my question is a big one for a lot of organizations now is customer experience. We're building propensity models and alike. What about bias within our own algorithms? And is that a challenge? And how do we overcome that?
Yeah, you can have both data and algorithmic bias, and both need to be managed. I think there's a whole new paradigm around machine learning operations, which is very much the type of tools that have been put in place for years around software engineering. So DevOps. And how you deploy software and how you manage software lifecycle. And then organizations are really getting on board with MLOps, so machine learning, and how you manage the models, how you manage the algorithms, and how you investigate and test biases in the data sets and the algorithms as you deploy. So you can imagine that you can do this investigation up front. And my example, because it's the one that I've recently been working on, is looking at detecting shark species from drones. And you can get something working on a single beach, but when you deploy it to multiple beaches with different backgrounds and different conditions, it'll degrade. And you need to manage that by continually upgrading and retraining your model, continually changing your data set to represent the conditions, especially because over time, the reality will drift and your model won't. Reality will drift and your training data won't. And so you need to move that goalpost as a functioning system that is continuing to work. So machine learning models are not just for Christmas. They're a service that you provide in order to deliver some insight about the world, but they need to be maintained and loved and cared for. Hope that answers.
Got some questions from our nation's capital, so I might see if we can stream that audio in. And if you are there online listening, I think there's a 6-second delay as well, so we might just see.
That's just Canberra.
Yeah, you're online, Canberra. So I believe there's a question from Courgette.
Oh, yes. Can you hear me?
You can, yes.
Oh, great. Really interesting. 2 questions. So how do you avoid AI flagging too large a subset of variables that then flag for human review information that's just too large to analyze? I mean, you mentioned about the human interaction of, perhaps people being bored or not getting the right information. So that would be the first question. The second one was, we have recently heard about the impact on the environment of technologies such as Bitcoin mining. How green is our AI solution?
Great questions.
Who wants to take
To whom was it directed?
Anyone in
So, I mean, I'm happy to answer the second question first. I think the technology is deployed because, as we've already mentioned, the size of the data sets required involve the speed of the networks and things like that. So there's an element of, the power per device can be reasonably high, but the insight with which it can derive and the amount of other infrastructure that it removes out of that cycle that is, currently inefficient or not fit for purpose, I think is also, correspondingly large. So I think at any particular use case, you've got to have a balanced approach to how you measure that. There's also the element of versatility around it. So is it reusable for different purposes? There's a lot of effort we're putting into, the underlying technology that drives, and similarly with NetApp, this idea of, particular workloads by day and particular workloads by night. There's different cooling technologies we're using. There's different powering methods, that Fujitsu and their data center business is certainly, investigating, that's running these systems. So I think that's it's not a Bitcoining mining circumstance because the infrastructure here is quite versatile and there's different purposes it can be used for. I mentioned the graphics and the visualization side of things as well. So whereas Bitcoin mining really doesn't serve any other additional function other than, the currency or, whatever you care to define it as that sits underneath it. It's not particularly, it's a very special purpose.
Yeah, just to add on to, I think the solid state arrays we're using in the stack, the NVMe arrays, that they're a lot less power hungry than the spinning Rust machines we used to use in the past, in terms of power consumption too.
And when you add to that, you mentioned the data centers. So 3 of our data centers are certified to host the NVIDIA solutions, and these have the highest neighbors rating. So we have a lot of effort. We put a lot of effort in terms of sustainability, environmental impact. So we tackle it from all angles on that one.
Yeah, and just the first question, I mean, none of this removes the right of people to, ignore, warning systems or decision support systems, right? And people can and will continue to do that forever, I'm sure. I think what the specificity that which we're trying to make use of this test drive facility for is to give people a sense that the warning or the recommendations or suggestions they're getting are useful in the context of the business they operate. And if they are, then people will pay attention to it. If they're not, they'll ignore it and they'll file it away the same as they do with other software or, the alarm in the morning you hit snooze on, right? So, I think that's, it's how practical we make it, how quickly we make it practical in the context that'll drive that.
Yeah, I might add something there as well, if that's all right. So with regard to power usage, there are new technologies that are coming to the fore now, like federated learning, which move a lot of the power use towards the edge, towards mobile devices, and also make it so that you don't have to use very power hungry large data appliances to train a model. You can train a model and front load that power use at first, and then your updates can be done in a very low power mode on the edge, and also in a very private mode where you don't have to share data, you just share what is learned. So that's a sort of a very active area of research. To answer the question about the visualization, you can think of how you visualize your data as being almost like a cone. You can take a number at the very tip of the cone, or you can take a deeper and deeper slice where you get more and more detail. And it's up to you to decide what that target for your visualization is. And I think, sort of the GPU systems in use here will supply you with any particular target that you want. But that's a user design question, really. And there's no, the capability is there to do a number or something that's much more rich. It's just a question of how far back into the data set that you want to dig.
Great questions from Canberra. Thank you very much for those, and some really good answers there. Any other questions? We've got time for one more question, maybe from the Sydney audience. The mains are starting to roll out. It's always good to get questions. I might finish on one element, and that's probably the biggest buzzword of 2020, 2021, security. Obviously, CIOs and IT teams are sort of recognizing that as being the major challenge, and it's an agenda from the top, which is great. Any advice for sort of organizations that are looking at doing things like AI test drives and maybe, utilizing data and so on and so forth? What's the best way to wrap a good sort of security posture around these projects?
We'll start with you, mate.
Yeah, sure. I think in the way you protect any other data, you also need to classify your data, understand the regulations around that data. If you're in a healthcare industry, also it's a lot more sensitive. Finance industry, PCI compliance rules. We've already got a lot of regulations in the ANZ market to make sure you understand how you need to treat and manage data. And then if you look at what we're proposing today, there's multiple layers. There's software encryption, hardware encryption. There's encryption at flight for the data. Then there's also a whole layer of data security and compliance. So if you want to take a zero trust stance, we can help you understand how the architecture would work. If you want to build compliance in, so you understand what type of data is being dropped into S3 buckets in the cloud, for example, then we've got a software service layer that's constantly monitoring those buckets for you to make sure somebody doesn't accidentally put sensitive data in the wrong place and is proactively searching for it. So there's a whole range of services there that I think we can make sure that we can provide a really robust governance framework around your data.
Well, Mike, how do you tackle security with the work that you do?
Yeah, it's not really my area of expertise, but we have to think about privacy issues when managing data sets, especially. And so, data sets that we use, we anonymize them and we make sure that they are securely stored. So actually physically holding a copy of the data set in one place behind several layers of security of different sorts. But it's, as I said, not really my area.
It's bringing in the right people at the right
time. I think so. I think you need to go to the experts here.
But it's back to that expertise area I spoke about at the start, right? You're going to need a family of clever people to run your AI project professionally.
It really is a very multidisciplinary endeavor.
Yeah, fantastic. That's a great actual segue onto what I was going to know before we close up. We talked about the AI test drives. So for those online and in the locations, we've put QR codes basically everywhere today. If you'd like to book your test drive, that's not a check-in. Just take a photo of the QR code. 18 months ago, I'd never even used the QR code. And now they're everywhere. It's great. So all you need to do is just pop that through. Actually, we do have one more question from Canberra. I hate saying no to a question. Do you mind if we get one more? Yeah, because they were so good for the first one. Are you there, Canberra?
Yes, thank you, everyone. That's been really interesting presentation. You've touched on the opportunity to use AI for legislative drafting, interpretation and compliance. And I note that the previous speaker spoke about some of the challenges in AI adoption, and of those 7 top challenges, legal hurdles were identified. I'm really interested from a government perspective to understand whether those challenges are real or perceived legal hurdles, whether they're around largely privacy, cybersecurity, and possibly a need for greater trusting environment. And if so, what government can do to support industry to really progress that uptake of AI.
Go on.
Want to tackle that?
So I'm happy to take that one. So I think from a cybersecurity perspective, I mean, ultimately these are still, computer systems and storage. The underlying infrastructure matches, what's in use today, and the security, mechanisms and measures around that are well understood and continue to develop. The difference with AI, things operate better with more data. More data means more speed. So there is a push to make systems operate more quickly and in a more automated fashion than they otherwise would, for it to be as effective as it can be. So I think there's some there will be some stress and strain around some of that, and that will apply to legislation and things like that of that nature, which traditionally moves at a certain speed, you know, for very good reason. There may be areas where, you know, there's some requirement for trust or exploration where that may not have historically been the case. It won't be terrible outcomes if it doesn't. It just think that the advances may go a little bit more slowly if that's the case. You know, I think there's a huge interest, you know, from NVIDIA as a company in having AI put to practice for some of the more mundane, you know, tasks of government, whether that be compliance purposes, whether that, you know, most citizens want to be, you know, law-abiding and do the right thing, and then some things are more onerous or difficult to follow, and making those things easier for people to interact with and for government, conversely, to interact with, you know, with its citizens, whether that be here or elsewhere, is, you know, is something that we're very interested in and looking to make assistance available and around. So, you know, happy to follow up. I'm down in Canberra very frequently. So, assistance from government in putting some frameworks around that would only be beneficial, and we're seeing a lot of good support, you know, both in New South Wales and from Canberra around making that happen. So,
yeah, I might just add something. I think the key to deploying AI in any use case at all is validation.
Yeah.
You need to validate your proposition. What is it that you want to do? Let's run a test and make it as hard a test as you possibly can.
Mm-hmm.
And I think that's possibly something that the AI test drive facility is designed for.
Yeah.
Is that you can just say, okay, let's design an experiment and run it, and then see if we can get something to work. And that might be discovery of something in legal documents, or it might be something completely different. But do a test first.
Simple.
Yeah.
I think to add to that, when it comes to government, and we're talking about citizens, a big part of that is trust, right? So the data validation, to make sure that you know, the citizens have the trust in the outcome of whatever AI is doing. I mean, we all might remember robot debt. That's probably a prime example of how not to do it.
Yep.
So it is about, you know, validating the data and the transparency around it.
Yeah.
So trust is an important factor, less legals as well, but the trust is key in these kind of projects.
I thought we'd go over time today with the questions and the discussion. Can we have another round of applause for the panelists? That was sensational.
Thank you.
And a big thank you. Best location question winner, Canberra. They were great. So thank you very much for your contributions. And particularly on what is a freezing day, I'm hearing, so that's great. Guys, so as I was saying, it is about identifying the use cases, maybe starting small, getting the right IT ecosystem, which was talked about. So feel free to snap that QR code, and you can connect with a wider team and book a bit of a test drive and understand the technology a bit more. But super exciting space. I'd like to thank everybody for their contributions. Sylvia, did you have any final comments?
Thank you. Thank you for everyone, for the lovely panelists. Thank you to Alexander getting up at probably 3 a.m. to prepare for a 4 a.m. pitch. Thank you everyone for coming today. As I said, it's a real privilege to have you here and to launch our test drive in partnership with NetApp today. And as I said, great to have you here in person as well. It's been a long time.
Awesome. Well, what I'll leave the people that are at a venue is we'll now switch off all the digital and the thought leadership side of things. I'd encourage you all to continue this discussion on the table. Maybe discuss, you know, some of the use cases that you've seen within your organization, or some areas that you've been looking at. Also, skill set is a big one here as well. So with the senior audiences that we have, that might be a good point to talk about. So I'll leave that with everybody and wish everybody a lovely afternoon in finishing their meals in Canberra, Brisbane and Sydney. And everybody online, you better go and grab some lunch. The lunch here is horrible, I promise. So a big thanks, and signing off for everybody online, and have a great day.